9.6, solving nonlinear systems of equations. Okay, so we're going to, a system means we've got more than one equation. So here are some different ways this could shake out. These are all systems with a linear equation and a quadratic equation. So a quadratic equation is going to give us the parabola, right, in each of those, and then the straight line is the linear equation. And the intersections of the two functions are going to be the solution to the system. Okay, so you can have a line that doesn't intersect a parabola at all. In that case, you get no solution. You can get one solution if there's just one point where they intersect, and if there's two intersections like so, you could get two solutions. So all of those are options, so just keep that in mind when you're working on these problems. Okay, so here, these are really brief instructions here, but this is what you want to do. You want to graph both equations and then find the intersection. So you're going to find the xy pairs of the intersection, and that would be your solution. Okay, that's when we're solving by graphing. Okay, all right, so here is a system. I've got two equations here. So I'll graph this top one in red. I'll color code this a little bit. Okay, so this one I can see it's a quadratic equation because it's got the x squared. So it should be a parabola, and it's in standard form. So there is a number of ways you can go about graphing this. I definitely want to find the vertex. That's going to be super important. Also, I know that this parabola is going to open upwards because the x squared term is positive. If you had like negative x squared, it would open downwards, but that's good to keep in mind. Okay, so let's think about finding the vertex. I'm going to use the axis of symmetry. Okay, so the axis of symmetry, we've got a little equation for that. That's going to be the line, the vertical line that's in the middle of my parabola. And the equation is x equals negative b over 2a. Okay? So the a, b, and c, a would be 1, b is 4, and c is negative 4. Those are it's the coefficients of those two terms, and then the constant in that order. Okay? So in this one, the b is 4, and the a is 1. Okay, so I've got this, and I'm going to start simplifying this. On top, I just have negative 4. On bottom, I have positive 2. And then negative 4 divided by 2 would be negative 2. So the line x equals negative 2 is the axis of symmetry. So that means that's going to be where the vertical line is. So I'm just going to lightly do this. So there's the middle of my parabola. Okay. And so that means that the vertex is going to be somewhere on this line because that's the middle of the parabola, okay? So for the vertex, we already know the x-coordinate of the vertex because any point on this line has an x-coordinate of negative 2, right? So I know the x is negative 2. I just need to figure out what the y is. And the way I'm going to do that is I'm going to go back to this equation. I'm going to plug in negative 2 for x to see what y goes with it, okay? So I'm plugging negative 2 in for that first x. I'm also going to plug it in for the second x, like so. And then I'm going to use PEMDAS to sort this out to see what y goes with an x of negative 2. Okay, so squaring negative 2 times itself is positive 4. 4 times negative 2 is negative 8. So I did the exponent first, then the multiplication. Now I've just got a subtraction left, so I'll do this subtraction first. So, sorry, 4 minus 8 is negative 4, and then I'm subtracting another 4, so that gives me negative 8. So that means the vertex is the point negative 2, negative 8. So that is right down there, okay? Now I know this is going to open upwards, so there's a number of things you could do now to find some more points. The easiest other point to find would be the y-intercept, because the y-intercept, that's going to be where my parabola crosses the y-axis, and the x-coordinate has to be 0. So you just plug in 0 for x into the original equation, and you might notice those first two terms are just going to disappear. So it's really the c. The c, when you're in standard form, the c is always going to be the y-intercept for a quadratic equation. So that means I've got this point here at negative 4, okay? And then, so I can reflect that since this is going to have a mirror image on the other side of the axis of symmetry. So I could go like that. Okay. Another thing you could do is make an XY table. Just start plugging in some different X values and get some Y's that go out with it. You could also use just what the parent graph of this looks like, if you know that pattern. Okay. All right. So I know my parabola is going to look something like that. So I'll just do a little sketch. That's kind of enough to get a basic sketch of what this looks like. Okay. There's my first equation. Okay. Now the other equation, I'll just do this one in a black pen here. Okay, that's a linear equation. And so for this one, I can see the slope is going to be 2 because this is in y equals mx plus b form. So the m part is 2, or you could think of that as 2 over 1 for rise over run. Okay, and then the b is the negative 5. And the b is going to be the y-intercept. So I'm going to start with the y-intercept right here. Okay. And then from there, I'm going to go up 2 to the right 1 to get to another point. So I can go up 2 to the right 1, up 2 to the right 1 again. You can keep going up 2 to the right 1. You can also go down 2 to the left 1. Because if you think about it, negative 2 over negative 1 is actually equal to positive 2 over positive 1, right? So I can go down 2 to the left 1, down 2 to the left 1, okay? And now I would draw in my line. I forgot to get a ruler out, so I'm just going to freehand it. That's something like that, okay? So now I've got both of these graphed. I graphed the system, but now I still need to find the solution. And so what I want to do is find the intersection, a point that's on both the parabola and the line. It looks like there's only one of them. It looks to me, just eyeballing it, that this is the going to be the solution. But we can double check this by just to make sure that this would be the point. Let's see, that'd be 1 left, 7 down. So this would be the point negative 1, negative 7. Okay, and we already know that this is on the straight line because we graphed that point to graph the straight line. But we can check just to make sure that it is on the parabola as well. What I could do is plug in negative 1 for x into the original equation. Okay, so let's try that really quickly. So down here, I'll put in negative 1 for x. And I want to see if I get negative 7 out. Because if I plug in negative 1 for x and I get negative 7 out for y, then I know that point's on the line. Okay, so negative 1 squared is positive 1. Then I'm doing the multiplication there. Let's see, 1 minus 4 would be negative 3. And then negative 3 minus 4 is negative 7. So that point is on the parabola as well. So that is my solution. And you could write this as an ordered pair, or you can say x equals negative 1 and y equals negative 7. That means the same thing, right? So that means that this xy pair will satisfy both equations, okay? And we've solved that system. So this is not the only way to solve a system of equations where you have a nonlinear function. You can also use substitution or elimination. You can solve these algebraically in a kind of a similar way that we would use substitution with if you had two linear equations. You can do the same kind of thing when there's a quadratic equation involved as well. Okay, so let's solve this nonlinear system. We do have a straight line in there, but we have something that's not a straight line. The second one's a parabola there. Okay, so I'm not going to graph these. I'm going to use substitution. All right, so use substitution to solve for one of the variables. Okay, so you really need some experience with solving linear systems. But what you want to do is get either the x or the y isolated in one of the equations. So I see in both of these the y is already isolated, okay? So I could isolate the x up here, but the y is already isolated, so I'm going to go with that. So I'm just going to use the top equation. This says that y equals negative 5x. So what that means, in the other equation, I can substitute in negative 5x for y, because negative 5x is equivalent to y. Okay, so that's what I'm going to do. So now I've got negative 5x equals x squared minus 3x minus 3. Okay, so now I've written one equation that has only one variable. So there's only x's in this equation, which means I should be able to solve this for x, okay? So my next step is going to be I want to set the equation equal to 0. I don't want this equal to negative 5x. So I'm going to add 5x to both sides, and I'll add it to its like term over there, because then we're also combining like terms at the same time. Okay, so now I've got 0 equals x squared. Let's see, negative 3x plus 5x would be 2x minus 3. Okay, now solving this, there's a number of things you could do. I like to always try to factor first if that's possible. So that's what I'm going to do here. All right, so I'm going to set up a diamond problem. So I'm going to put the 2 on the top and the negative 3 on the bottom. Now I'm looking for two numbers that add to 3, same two numbers multiply to negative 3. Okay, so let's see. Let's think about different ways we can multiply to get negative 3. There's not that many of them. Those are my only two options, really, to multiply to get negative 3 using integers. Okay, and then this one is the one that's going to add up to positive 2. So that's the solution to the diamond problem. And what that does is that tells me how this is going to factor. I know I have x's in front if you think about foiling to get the x squared. So I just need to figure out what goes in the back, and that's those two numbers, the solution to my diamond problem. And you could have them in either order, but there they are. Okay. Now that I've got this factored and set equal to 0, I can use the 0 product property. Okay, these two things multiplied together equals 0. So that means it has to be 0 times something or something times 0. So x minus 1 equals 0 or x plus 3 equals 0. Okay, and then I'll add 1 to both sides here, and I'll subtract 3 from both sides here. And now I've got those two x values. Okay, and it kind of feels like I'm done with the problem because, hey, I found x. But you got to remember, we're looking for an x and a y, okay? Because this is going to be a straight line and a parabola. And I know this one particular one's going to have two intersections because I found two different x coordinates, but I got to find the y's that go with them, okay? So the second step here, it says substitute the value of the solved variable, so we solve for x, into both of the original equations. Okay. So now what I want to do, actually you don't need to go into both equations, you can go into either one. So I'm going to pick one of the original equations and I'm going to plug, I'm going to change this. I'll change that on the note-taking guide. So I'm going to choose the top equation because it's simpler, okay? So I'm going to take the x equals 1 and I'm going to plug that into this top equation. So I'm plugging in 1 for x, and then negative 5 times 1 is negative 5. So that means when x equals 1, y equals negative 5. Okay, so that means this is one of my solutions. That's one of the intersections. But we've got a second intersection. And you could plug it into the second equation too, just to make sure that you also get negative 5 when you plug in 1 for x. Okay, but I've got to also still do this piece. Okay, so I'm plugging into the top equation again just because it's easier. And now I've got when x is negative 3, y is 15. Okay, and there's my other solution. And you could say x equals 1, y equals negative 5, and x equals negative 3, y equals 15. But you'd want to group them. You'd want to show when x equals 1, y equals negative 5, right? And you want to group these two as well. So I think when you get multiple answers like that, it's probably better just to list your answer as an ordered pair so that they're already grouped together. Okay. All right, let's solve this one by substitution. This one's actually pretty simple because if you look at the bottom equation, it says y equals 9. Well, that's telling us what the y coordinate is, right? We already know, so, you know, here we had y of negative 5 and positive 15. Here the y is just 9. So that means we can just take, okay, y equals 9. So let's plug 9 in for y into the other equation. Okay, so I'm going to plug that in to the top equation. So now 9 equals x squared plus 9, and we're going to solve this for x. Okay, so I want to get the x term by itself. Okay, I'm going to subtract 9 from both sides. 0 equals x squared. And now I'm thinking, what times itself equals 0? Well, that would be 0, right? Or if you take the square root of both sides, the square root of 0 is 0. So that means x is going to equal 0 here, okay? So that means when y equals 9, x equals 0. So my solution is going to look like that. Or you could just put a box around it. Y equals 9, x equals 0. Oops, I'm off screen there. But make sure you don't get them flipped, right? The x would go in front and the y would go in the back. Okay. Okay, you can also solve these systems using elimination. So let's take a look at that method on the last page. Okay, so when we're doing elimination, we want everything to be lined up. So it says line up all of the like terms in both equations. So you can see the y's are already lined up here, right? But then we've got an x squared that's on top of an x term, all right? And you might notice on the second equation there is no x squared term. So what I like to do is to, if either one of the equations is missing something, I'm going to add in an x squared term. I'm just going to add in 0x squared, okay? So I'm going to write this second equation like this. Because 0x squared is just 0, right? But now it's going to line up nicer with the top equation. So the top equation is y equals x squared plus x. Now the top equation doesn't have a constant term, so you could also put in just a 0 there. And now everything's nice and lined up. Because the idea here with elimination, we want to treat it like a big addition problem. You could also do it with subtraction. I like to always do it with addition, okay? And when you add these two equations together, you want one of the variables to eliminate, okay? So if I added it like this, y plus y is 2y. And then, you'd have x squared, 1x squared, you'd have 2x and 5. So if you add them together like this, neither one of the variables will eliminate. For problems like this, I always try to eliminate the y's. It's just easier because there's less to deal with. So I want those y's to be opposites. Now, if you did subtraction, you could eliminate it right now, right? But what I'm going to do is take one of the equations and multiply everything by -1 so that I get a positive y and a negative y. So I'm going to multiply the second equation by -1. I'm going to leave the top equation as it is. So I'm just rewriting it. Okay, bottom equation, I'm going to take the opposite of everything. I'm multiplying everything by -1. So I have negative y. There's no such thing as negative 0x squared. The opposite of 0x squared is just 0x squared. Okay, and then the opposite of x would be negative x. Opposite of 5 is -5. And now when I add these together, the y's will eliminate because y plus -y is 0. Okay, x squared plus 0x squared would be x squared. X plus -x is also 0, and then 0 plus -5 would be -5. So then I can say that this is 0 equals x squared minus 5, because we don't really need that 0 there, right? So now I've got an equation that only has one variable, and I can solve this then for x. So I want to isolate the x squared term, so I'm going to add 5 to both sides. So now 5 equals x squared. And then I want to take the square root of both sides. And don't forget, when you take the square root of both sides of an equation, there's a positive root and a negative one. So x is going to equal positive or negative square root of 5. Okay. Now you could leave the x's like that. It's not a perfect square, so it's not just going to be an integer. Or you could do a decimal approximation. So the square root of 5 is about, I'll just call that about 2.2, okay? So I could say x is about positive and negative 2.2. Maybe I'll call it 2.24 to go the nearest hundredth, okay? All right, so now what I want to do, I've got the two x coordinates, but you remember we're going to be looking for the y's as well, because here we've got a parabola and a straight line. So I need the xy's where they intersect, right? And now I've got the x's. So what I'm going to have to do is plug in positive 2.24 into one of the equations, and I'm also going to plug in negative 2.24 into one of the equations, Okay, now you can choose which of the original equations you want to plug this in to. I would definitely use the second one just because it's simpler. Okay, so I'm going to plug both of these into this one, into y equals x plus 5. So plugging in 2.24 plus 5. Now I put that approximately equal sign because the 2.24 is rounded. Okay, and then 2.24 plus 5 would be 7.24. So that means when x was about 2.24, y was about 7.24. Okay, and that would be one of the intersections. So one of the solutions. And now I'm also going to plug the negative 2.4 into y equals x plus 5. Okay, and let's see. Now I've got negative 2.24 plus 5 is going to give me 2.76. Oh, I don't know why I had that in parentheses there, sorry. Okay, so that's about 2.76. So that means when y was negative 2.24, sorry, when x is negative 2.24, y came out to positive 2.76. Okay, and there's my solutions. Okay. All right, let's try another. So I want to get everything lined up just like I did on the previous problem. Y's and the equal sign's already good to go. I'm going to insert a 0x squared into that second equation. Okay, and then the top equation, just going to write it as it is. Okay, now everything's nice and lined up. If I add everything together now, nothing's going to eliminate. So just like the last problem, I'm going to eliminate the y's by multiplying one of these original equations by negative 1. You can choose which one. I'm going to leave the top equation alone and then take the opposite of everything in the second equation. Okay, 0x squared doesn't have an opposite, but then opposite of 5x is negative 5x, opposite of 4 is negative 4 is positive 4. All right, and now these are ready to add together. Okay, the y's add up to 0, so the y's eliminated, that's what I wanted. 9x squared plus 0x squared is 9x squared, and then 8x plus negative 5x would be 3x, and negative 6 plus 4 would be negative 2. Okay. So now I've got this equation, and this is a little bit harder than the one we wound up with in the previous problem after we did the addition, because we've got an x squared term and an x term. So that's okay though, it's a quadratic equation. We've solved lots of these before. There's a couple options. We could factor, we could use a quadratic formula, or we could complete the square. My choice is going to be to factor. I always usually try to factor. And if it's not factorable, then I use one of those other methods. So I'm first looking for a common factor. Does anything go into 9x squared, 3x, and negative 2? And there isn't anything, okay? So now I'm going to just factor. This is all still going to be equal to 0, right? But I'm just doing the factoring here. I'm going to do a modified diamond problem, okay? So you can't go straight to a diamond problem because of the 9. Because you have a coefficient in front of the x squared. So I'm going to take that 9 and multiply it by the negative 2. 9 times negative 2 is negative 18. And now I've got a trinomial that I can use a diamond problem with. So I'm going to put the 3 on top, negative 18 on bottom. And then I'm looking for two numbers that add up to 3, and the same two numbers multiply to negative 18. So I'm just thinking, can I do something with a 1 and an 18? Because those would multiply to 18. I know one of them would have to be negative, but I can't get to 3 with a 1 and an 18. Can't do it with a 2 or and a 9 either, but I can do something with a 3 and a 6. Okay, so if, let's see, with a 3 and a 6, those would multiply. I need one of them to be negative to multiply to negative 18. And I want them to add to positive 3, so that means I'd want the 3 to be negative and the 6 to be positive. Now those multiply to negative 18, add to 3, okay? So that tells me how to factor this trinomial, okay? But then I changed this this trinomial at the beginning, so now I got to change my factored form here. So in the beginning I multiplied by 3, so now I'm going to take the number parts and divide those by 3. Just these parts, okay? And the next step would be to reduce these fractions as much as I can. So 3/9 reduces to 1/3, and 6/9 reduces to 2/3. Okay, now when you've reduced all the way and you still have fractions, then you pull the denominator out in front of the x on both of these. So that would give me 3x, and then the 1 falls to the ground, okay? And here I've got 3x, and then the 2 falls to the ground, okay? And now I've factored this trinomial, so this is all equal to 0, okay? And this is taking a little while, but now I've got this ready for the 0 product property. So I know one of these two things has to equal 0. So either 3x minus 1 equals 0, or 3x plus 2 equals 0. And I'm going to solve both of those for x. Okay, so on this one I'll add 1 to both sides, and then divide by 3. So x is 1/3. On this one I'll subtract 2, and then divide by 3. And I got -2/3. Now those are my x's, but I still need the y's that go with both of those. So this is a long problem, right? So I'm going to plug both of these into one of the original equations. I'm going to choose this one just because it's simpler. So I'm taking y equals 5 times that x value minus 4. And over here I'm going to do y equals 5 times -2/3 minus 4. Okay, and now I'm going to solve both of these. So let's see. Y would equal 5/3 minus 4. All right, I want a common denominator. So I'm going to multiply the 4 by 3/3 so that they both have the same denominator here. So y equals 5/3 minus 12/3, and that's going to be -7/3 then. Okay, so when x was 1/3, y was -7/3. Okay, over here, let's see, I've got 5 times 2 would be 10, so this is -10/3 minus 4, and I need a common denominator again. Here, maybe I'll just split that up visually there. Okay, so now I have y equals -10/3 minus 12/3. And -10 minus 12 would be -22, so this is y equals -22/3. Okay, so when x was equal to -2/3, y was equal to -22/3. Okay, yeah, that one took a while because, you know, we had to solve this quadratic equation, and then we also had some fractions we had to deal with when we plugged the x values back in. But there it is. Okay, that's the end of the section. See you next time.